and welcome to Wildly Curious, where the questions are unhinged, the science is real, and honestly, we're just getting started. I'm Laura.
And I'm Katy. And...
Ever wonder why a bat might glow? Or how frogs made it to space long ago? Dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Wildly curious, where science gets strange and kinda hilarious. For nature's wonders to ancient funk, it's facts and fun rolled into one big chunk. Wildly curious, we're just wonderful. Come join the fuss.
This is another episode where we do a deep dive into a group of animals, and this
It's been
one,
a while.
Yeah, it's been a while. It's been a while since we've done a deep dive, but these are the ones where we break down like a taxonomic group and kind of talk about more of the details of what it is and everything. Which honestly, it sounds like they should be our more boring episodes, but they end up being some of our most interesting episodes for sure.
Yeah, it's the heavier science stuff, but sometimes it's just fun to really dive into something.
Yeah, and I think with this group, it's definitely going to be more of that. So we're going to be talking about echinoderms, how they're hard on the outside and squishy on the inside, but they're definitely an odd grouping of animals that this is one of those ones where I get why they all put them together, but at the same time, I don't.
Yeah, there are a lot of differences between them. I just remember this was my favorite group.
This was
my
a fun
favorite
group.
taxonomic group to dissect.
Yeah. 100%.
I love to dissect.
And we're not talking about dissecting, deep dive into talking. No, we're talking about literally dissecting them. Yeah. All right, Laura, you had nature news then?
Just real quick, last week I saw in that Science magazine posted in a new science study, researchers report that bark microbes process methane, hydrogen, and carbon monoxide, showing that bark is an important component of global trace gas dynamics. It's not just the leaves soaking in the carbon dioxide. It's actually the microbes living on the bark making significant contributions.
Man.
It's all connected.
Right? Because that's what I was going to say. Again, it's like the fungus in the ground that's spreading nutrients, moving nutrients and stuff within the roots. Then you have this, trees really are just
they're the best.
Yeah, like an ecosystem in themselves. It's crazy.
Oh, yeah.
Crazy. All right, so we're going to break down this episode. I'm going to go over the characteristics of echinoderms. Laura's going to talk about the different types. And then we're going to do 2 different species highlights. Laura's going to talk about sea cucumbers, where I try not to make wiener jokes. And then I'm going to talk about starfish, or one particular type of starfish.
Let's do it.
Alrighty. So what even is an echinoderm? Like I said, to me on paper, this is a group that just doesn't work for me because biologic, it doesn't make sense.
Remember how, if you've ever listened to these past episodes, these characteristics are never 100% because nature always has exceptions. Scientists are just doing their best.
Yeah, but I feel like this group is so disconnected. So the general idea of this group, what are echinoderms? We're talking about our starfish, sea urchins, sea cucumbers, and then a feather star. So just think of the grouping that they really have, other than literally hard on the outside, squishy on the outside. I'm going to talk about their characteristics, but it just, at first glance appearance, you're like, this is not, there's no way that this is the same group of animals. It's hodgepodge mismatch stuff that scientists are like, group them together because they don't know what else to kind of put them through. Yeah. So the first defining feature of echinoderm is actually right in the name. Echino, which means spiny, and derm means skin. So at the most basic level, the only thing these things really truly have in common is spiny skin of some different length,
some level
density,
of spine.
all that stuff. Yeah, some level of spine, because some of it barely noticeable. Others, like sea urchin, you can clearly tell. Underneath the skin, echinoderms have a series of tiny skeletal plates called ossicles. These are made of calcium carbonate, the same material that you would find in a shell or anything. And these form an internal skeleton that gives the animal structure and protection. Which to me, I'm like, okay, wow,
in
a shell
the
is...
roughest sense of the word, right? Skeleton. Yeah.
Yes. Yeah. No, right? Yeah, because it's not... I was like, man, no wonder you could, squish it. It doesn't...
It's just a seashell under skin.
Yeah. Oh, that's a horrible horrible image. But so even though they they're soft, they look soft, they do have some rigidness
some
to
crunch.
it. Yeah, some crunch. So that is an important distinction here, is that echinoderms are not soft-bodied animals like a sea cucumber looks, because it looks like one of those you know those toys that we had where it's like whoop, whoop,
I know
and
exactly.
it kind of folds in on itself.
Yes.
You know what I mean? Yeah, it's like liquid in there. Like it looks like that's
foreskin.
what it. Yeah, that's what it should be, but it's not. Like a less squishy blob. Another defining feature of an echinoderm is their symmetry. Most adult echinoderms have what we call radial symmetry, right? Usually arranged in 5 parts or multiples of 5. Starfish are the most obvious example, but you see the patterns in sea urchins, which again, when you're looking at a round animal and you're like,
radials.
There's symmetry. Dude, there's circles. What do you expect? Like, of course there's... But anyway, that's how they lump those ones in.
Yeah, and radial symmetry is it's little radii coming out from a center point rather than just chop it in half and it's the same.
Yeah. But again, if you're a circle, like...
You're both. You're like all the symmetry.
Right? Yeah. All of it. Like Laura just said, so instead of having a left and right side like we do, their bodies are organized around a central point. Okay, but here's the twist. It's a big one. So echinoderms don't start out this way. As larvae, they're bilaterally symmetrical, meaning that they do have a clear left and right side, just like humans, dogs, fish, whatever. And early on, this is going to be a normal animal. And then as they develop, they completely reorganize their body plan because I guess why not? And they abandon the bilateral symmetry and transition into this 5-part radial layout that they have.
Totally forgot about the larva stage.
Yeah, that's like complete. Again, it's so drastically different than the adult. I really feel like this is just the catch-all weird sea animals that scientists are just like, all right, you guys go together and here you go. And they found like whatever similarities that they had, that's a group, but it's really not anything major. Anyway,
we haven't covered jellyfish, have we? Have we covered jellyfish?
I thought so.
I just can't remember. Did we cover their insane life cycle?
I don't think we went through the life cycles. No.
Okay,
no.
I was just curious.
So the single, though, most important feature of echinoderms, the things that truly sets them apart, is something called the water vascular system. If an animal doesn't have this, it's simply not an echinoderm. So this is the one thing that joins them together. Yeah. Echinoderms don't move the way that we do. They don't rely on muscles pulling on bones in the same way as vertebrates do. Instead, they use basically pressurized seawater. Water enters the body through a small opening, moves through a series of internal canals, and is then directed into structures called their tube feet. So they're little feetsies, they're little tubulars.
Tube feet is so cute.
Right? So those 2 feet are doing almost everything. And if you've ever seen a sea star move across the ground, like this, it's the easiest way to see these kind of tube feet in action. They're used for movement, gripping, like with sea urchins, for holding onto surfaces, for handling food, and for sensing the environment. Each one can extend, retract, and attach using suction, all controlled by changes in water pressure.
Which is crazy. It's just a hydraulic system.
Yeah, like an internal mini hydraulic system of their own.
Oh, Lord.
Is that the cat?
He jumped up on my lap, but just...
Yeah, right in the claws. And once you realize it's a hydraulic system, a lot of their movements and just behaviors in general starts to kind of make a little bit more sense because they can pry open shells or cling onto rocks or cling onto rocks over strong currents. And so it makes sense whenever you're like, oh, a hydraulic system, if it's sucking that hard. But like us, like how would you hold onto a rock surface, flat rock surface with a strong current? Like we could not do it. Yeah, but they have
like the way the rolling movements too. Like the rolling movements definitely water here inside.
Yep. So once you understand the water vascular system that they have, the tube feet stop being kind of like a background detail and start being truly the main event of what brings them all together and really is their whole behavior system is all at some point starts with their tube feet. So echinoderms use those 2 feet, like I said, to grip surfaces, hold on to prey, manipulate food, and sense what's happening around them. Each foot can independently extend, attach, release, and retract, all controlled by water pressure. So it's not like all release at once, all suck on at once kind of thing. It's like independent stuff.
There's so many of them. Like if you've seen them move on glass, it's so many. It's almost like tentacles.
Yeah. Tons of individual ones. Yeah. And this is important, especially important having these 2 feet for animals like starfish, like we talked about, where the 2 feet plays a direct role in feeding. They use them to latch onto prey, to apply the steady pressure to pull open shells and everything. So they need, like, their whole life cycle really depends on it. So one of the most common misconceptions, I would say, about echinoderms is that they don't have a brain, right? Because a sea cucumber...
They look so... They don't have eyes. They don't have... At least... They're not, like, identifiably animal.
Yes. And so, to a lot of people, we assume simple equals unintelligent. And it's true that they don't have a centralized brain like we do, but that doesn't mean nothing's happening upstairs. So instead of a central control center, echinoderms have a system of nerve rings and nerve cords that extend throughout the body. This creates a decentralized nervous system where control isn't focused in one place, which is really freaky if you think about it.
So weird to think about. Like, how does that even work?
Yeah, right? So information is processed locally and on different parts of the body can respond independently. So that literally is, oh, your arm has a mind of its own thing. No, it literally does, if you're a starfish, have a mind of its own.
Do you think it's like 5 different people in there? You know, like if you've got...
I know what you're saying.
5 centralized... I mean, obviously it's not like that, but I was trying to think... We try and think about what things would be like if we were in that situation. Is it like 5 things reporting into one, like... We're just telling each other, hey, over there's food. You're right, there's no central. Oh, man.
Yeah, there's no centralized. So an arm can react to stimuli, like a starfish, right? So our arm can react to stimuli, move, and coordinate with the rest of the body without needing instructions. Because, again, everything that we do is up here. And so everything in our brain is sending instructions down. They don't have that centralized.
So it's just 5 different people all talking and figuring out how to move together, but also could just go rogue.
Yes. I mean, yes and no. I think I think it doesn't go rogue because it's, even though it can operate independently, it's still thinking of the whole. Does that make sense? Right. And this setup still has some really big advantages. So when control is spread out like that, losing a body part isn't as catastrophic as it would be for most animals. So it's really not no thoughts, empty head. It's just thoughts are everywhere through the whole thing, which is crazy to think about.
Yeah, it's really not something that we can comprehend.
Yeah, because it's
too different.
Yeah, it's so different. Another defining feature of echinoderms is their ability to regenerate. And this isn't a rare or accidental thing. It's built into how they survive. Many echinoderms can regrow lost body parts, whether it's spine, arms, or other structures damaged by predators or the environment.
Wait, spine? Wait, they don't have spines. Oh, well, like you mean like the...
Yeah. Not like the backbone spine, but like the pokey parts. And being able to regrow this stuff, it's really is a core survival strategy. When you live in an environment where things are constantly trying to bite you, tear off pieces of you, because again, you think about how everything that they're doing moves, like with those suction cups. You're not exactly stellar fast athletes down there swimming to get away. You know, you're kind of stuck with what you got.
It's like a 5-legged race. Like, like the organism is literally having to work all together.
Yes.
It's hard enough for one person to run, much less 5 people tied together.
Right. So because of that, things are going to get bit off and everything. And they're just like, well, that sucks. And they just keep going on.
There goes Joe.
No, not Joe. Like, and they just move on with their life because it allows them to keep functioning after a series. Because you think about another animal. If another animal lost a whole limb, you're out for the count. If you don't die from that, you're going to be gone for a long, long time. So at this kind of level, regeneration is about persistence, staying alive, staying mobile, and continuing to feed. So again, their quote unquote intelligence is survival. It is, well, lost a limb, still got to get food. And so it just keeps going regardless of what happens. So if you're trying to figure out if something is an echinoderm, there's a pretty reliable checklist. If it has a spiny skin, even if you can't, this thumbs up, man. I can't start with my pointer finger.
Number one.
Yeah, number one. If it has a spiny skin, even if you can't see the spines right away, you have to look closely, which is kind of a ripoff. An adult, again, and as an adult, it has a radial symmetry, which usually... Not balloons.
Peace signs mean balloons.
Hold on, wait. Let me see.
It only ever does it like one.
Yeah,
nope,
it's why is it peace sign is balloon celebration? And thumbs up is a bubble with a thumb. I give up. I just can't talk with my hands. So as an adult, it has a radial symmetry, usually in some version, like I said, of 5 parts. It moves using the water vascular system with 2 feet doing most of the work. And it doesn't have a centralized brain, relying instead on the decentralized nervous system. Again, if something goes wrong, damage, whatever, regeneration is already built into the plan to be like, boop, let's just go ahead and fix this.
Yeah.
So those are all the major characteristics of echinoderms.
So I'm going to talk about, with those characteristics, scientists have then divided them into different types, essentially.
Or so they claim. I still think that this is a hodgepodge.
As best you can, put them together. Because, scientists like to classify things, kingdom, phylum, class, order, all that stuff. So this is the next level down. We got from echinoderms to, here's the different types. All right, first is crinoidea, which are sea lilies and feather stars. This is something maybe you all haven't heard about before, if you're not ocean people. They're just
not ocean people.
You know what I mean? Like, everybody's heard of a sea star or a sea urchin.
Yeah, but if you look it up, I'm sure if you're interested in science, animals, whatever, because a lot of like nature documentaries have definitely hit on this one. Yes. So just look up a picture and then you'll be like, oh, okay.
They're also just known as crinoids, but sea lilies or feather stars are like the common name.
Yeah.
These things usually have a cup-shaped body, and they have 5 or more arms edged with feathery projections. So they look actually a lot like a plant, hence the name sea lily. So some people might think that it is just a plant, but it's not. It's one of these echinoderms, so it's an animal. The little feathery projections that come off the arms sense the world around them and contain their reproductive organs. The arms just waving
weird.
Around, being weird, trapping food, sending it down the grooves to their mouth part with little cilia. And so they're just filter feeders just hanging out with their arms flailing in the sea. They can swim if they really need to. They can detach and just away.
Yeah.
Most are in the deep sea. Some are in coral reefs. And there's actually about 700 different species.
Oh, jeez.
Crinoids.
Yeah, that's a lot.
Then we got the ones that people are more familiar with. The Oidea, which are sea urchins and sand dollars, which also don't seem like they should even be the same thing either.
It really doesn't. Yeah.
You go from a spiny ball to something totally flat. But yes,
I'm telling you, this is the miscellaneous. This is the miscellaneous group of ocean animals. They're just like group them together, whatever these things are.
Yeah. So they're lumped into 2 groups. Regular, okay, which are the sea urchins.
Just regular.
Scientific terms, regular. Yeah. Sea urchins, which typically have longer spines, some of which can even be venomous, like if you step on them.
Yeah.
And they typically like to live in rocky areas, which is why they have all the little spines so they can wedge themselves in. And then there are the irregular ones, which are the sand dollars. Sand dollars don't have the spiky projections. They're not like the things that you buy at the beach either, because that's that internal skeletal thing. But they're covered in not much else, just like a skin. And they like sandy areas. That's why they don't have the spines. So they have that hard, what's called an endo, meaning internal skeleton, made of those fused plates. This skeleton thing is called a test, T-E-S-T. And that's what you're buying whenever you buy a sand dollar. They're
Or find one. You can find sand dollars all the time. Yeah.
They're just so fragile. They also have a weird, complex mouth with 5 jaws, which I don't remember learning about.
I didn't know that. Yeah.
Yeah. 5 jaws, called an Aristotle's lantern. Cool.
What?
I just feel like that's a fun trivia word. You need to know. Aristotle's lantern. What does that refer to? The 5 jaws.
Also, what kind of band name is that? Like,
totally. Aristotle's lantern.
Like,
people wouldn't know what that means.
It's got to be metal, right? It's got to be like a heavy metal band.
I think so.
Yeah.
You can find these guys from the shallow intertidal zone. So if you're just searching in tidal pools, all the way to the deep ocean. They're pretty vast, about 940 species.
Dang.
Asteroidea. You can probably guess what that is. Aster meaning star, so these are the starfishes or the sea stars. Typical echinoderm, the thing you're all thinking about. They have arms and rays that surround a centralized, indistinct disc, like you can't see it. It's there. And their arms can be anywhere from 2 centimeters to 1 meter in length.
Which is nuts, yeah.
Yeah. The majority have 5 arms, but some can have up to 40. So like Katie was saying, is it denominations of 5? How am I saying?
Yeah.
Okay.
But it's not denominations. That's
the
church
term
groups.
I'm looking for? Wait, no, common denominator.
Yeah, okay,
So
okay. But it's not a denominator of 5.
I don't know. Denominations is what I said.
Groups of 5.
Okay. We're science people, not math people.
Yeah, right. We stay away from math.
There are 1,500 to 1,600 species. Vast majority of live in the ocean, but a few actually do live in brackish water. And
I thought you were going to say they don't live in the water. I was like, what?
Yeah,
I was like, how did I miss that? They're just crawling on land. Yeah.
And here's definitely where Katie's point is of they're just lumping things in now. So recently, and I'm talking 2006, so that's pretty recent for science.
Yeah.
Sea daisies have also been thrown into this group. Okay,
They're like,
so
why not?
Starfish, sea stars, and sea daisies, which if you look up a sea daisy, you're like, this looks nothing like a starfish.
Right?
They were discovered in 1986, so we actually haven't even known they existed for that long. They are flat and disc-shaped with no arms. So what do you have to do to be in this group? Nothing about arms. They have a double ring water vascular system, and the only places they've ever found them, they've only found 2 species because they've only found them 3 times. One's off the deep ocean of New Zealand, one's the Bahamas, and somewhere in the northern central Pacific Ocean, like by accident.
What?
So who knows where they're living.
Right?
2 more. Hold on, this one's a hard one. Ophiuroideae, which is basket stars and serpent stars and brittle stars. These have 5 arms that are really long and slender. They're kind of creepy.
Yeah,
creepy. These are like the gothic starfish.
Or the breakable ones. Like, I always look at them, I'm like, man, those things are so breakable.
Snap right off.
Yeah.
Yep. They're like known for easily discarding parts of their arm or their entire arm. Doesn't matter. They don't care.
Well, yeah, whenever they're that fragile, like at least a starfish has like some beef to it. You know, it's got some meat to it.
They look, beefy.
Yeah, these ones
do
don't.
not. This is the slender man of the ocean.
Yeah.
Basket stars take it to a whole nother level because not only are their arms long, but then they also branch into multiple things looking even more plant-like. They can be found from intertidal to abyssal, so from the deepest of deep all the way up. And they can be carnivores, filter feeders, and scavengers, and there's about 2,000 species. So there's a ton of those. Ton.
Yeah.
Like, I think it's the most of any group.
I also feel like that's such a big group that they're like, this kind of looks like it. Just throw it in with the sea stars, you know what I mean? Yeah.
Last one is Holothuroidea, which I remember learning this group because it's such a nerdy thing to do. But that's what we used to say to remember. It would be like, Holothuroidea. Sea cucumbers. Most are black, brown, or olive green in color. So like pretty drab little creatures. Anywhere from 3 centimeters to 1 meter. So again, pretty
big.
different.
Yeah.
Pretty big sea cucumber there. With an average, though, of 24 centimeters, which is about 20 inches long. Wait, no. Average is a diameter of 24 centimeters and 20 centimeters long. So like thick.
Yeah.
They're sort of worm-like, but they can be more spherical. These, of all of them with the hardened endoskeleton, these have the most reduced amount. There's barely any crunch inside these guys.
Yes.
A little bit of crunch.
Again, it's like those, you know what I'm talking about? Those,
Yep.
they have the glitter liquid in
Yeah,
them.
totally.
Yeah.
They are suspension or deposit feeders. These guys don't do much.
Yeah. I mean,
they
what would
just
you do
hang
if you're
out.
just a slung on the ground? Like, there's not a
You're
whole lot you
literally
can do.
like less active than a sea slug.
Yes, exactly.
Like,
Yeah.
yeah. Less active. They just debris and plankton just fall down onto them and then get stuck onto their mucus covered tentacles. And then they just move it to their mouth.
That's such a lazy way to eat, too.
Yeah.
Like, they figured out evolution so well that they're like, this is the path of least work. Just waiting for shit to fall on me, and then
Some
just like, la, 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 and it right to your mouth.
Some are sedentary, while others do move around some. And they can be found anywhere from shallow water to deep ocean. And there's about 1,100 species. So, huge differences in types.
Yeah.
All have the water vascular system and a couple of those other things Katy was saying.
Yeah. The sea cucumber is the one that I have direct experience with, because whenever I was on the Great Barrier Reef in Australia, one of the dive masters, because they knew I was a biology student, and so they were dragging me around through the ocean because they were like, look at here, look at here, look at here. And I was treated like a freaking queen that day. And so one of them dove down, came up, it was real excited, took off his mask. He's like, look what I have. And had a sea cucumber in his hand. I'm like, you're not supposed to touch stuff, right? And he's like, touch it. And I remember being like, bloop. He's like, cool,
yeah.
huh? And then he like took it back down. And I was like, that was a sea cucumber. So
I found a wild sea cucumber once, just when we were at Chincoteague. It was just under a bridge.
I missed that
So
place.
it was totally just like a brown green. I mean, it literally looked like a pickle.
Yeah,
Like,
no, straight up. And
was
this
just
one
a
was
little
big,
pickle.
but it was like a big pickle. Like, that's all it looks like.
I just
a
remember
huge
touching
pickle.
it and it went like, it shrank down like you didn't like it.
Don't
touch me.
You're like Stuart Matt TV. No.
Yeah, totally.
No.
Stop it.
Yeah. Such a good show. Alrighty. Is that all you had for those ones?
Yes, that's the type. So now you can go into your deeper species.
So I'm going to talk about one specific species. Laura's going to talk about sea cucumbers in general, because sea cucumbers are a little bit different. Like, I guess when you explain one, you explain them all, kind of thing. So
Yes, so
it's a moving pickle. Whereas like when you've seen one, you've seen them all. So
seen one pickle, you've seen them all.
Basically. So whereas like the starfish, there's a whole variety of them. So I'm going to focus on one, and it's the sunflower sea star. Okay, now if you Google sunflower sea star, you'll be like, oh yeah, because this is kind of like the freaky one. Not a freaky one, but like a lot of arms.
Freaky one.
Yeah. So commonly it's Phynodophia helianthorides. Close enough.
That sounds pretty good.
Yeah, it's commonly known as a sunflower sea star. It's a large sea star found in the northeastern Pacific Ocean. It's the only species of its genus, and it's among the largest of the sea stars in the world. With a this is the big one. This is the maximum arm span of 1 meter or 3.3 feet.
This looks like a face sucker.
Yes, it does, doesn't it? Like an alien's face sucker. Like
Because it's got too thick of a central disc.
It does.
It's not even the arms. It's that
no, it's
thick.
the set. Yeah, that it looks like it's gonna come up and.
Yeah, I wouldn't trust that thing at all if I saw it in the ocean.
No, right? I would be like this thing, like an octopus. Like, this is gonna come at me and just take my mask off, kind of thing. Adult sunflower sea stars usually have 16. Again, multiples of 5, I guess, don't care. So 15 to 25.
This one is like, nope.
Yeah. But they vary in color. Sunflower sea stars are predatory and carnivorous, feeding mostly on sea urchins. Yeah, faces.
You heard it here first, folks. Faces.
This is really the undersea killer. Forget any other predator.
just
all time. But
that's what they do to the poor things that they are eating.
No, it really is, though.
They really do that.
Is. If only they could move. If these things had an actual muscle system rather than like this tubular water vascular system, they probably would be way more like dangerous than they actually are.
Yeah.
So they were like one click shy of a better evolutionary background of being like
this
a
one,
fierce...
they'll come and get you, but you've got a little bit of time.
Yeah. You've got a bit of a wait.
So don't fall asleep underwater. Then you might get your face sucked.
Right, yeah. Yeah. If you have to be taking a nap on the bottom of the ocean floor, watch out, because here it comes. But it mostly feeds on sea urchins, clams, sea snails, and other small invertebrates. Although this species is widely distributed along the Northeast Pacific, its population has rapidly declined since 2013. And there's been several other species that we've seen this happen recently where it's just been okay, and then boom. So now they're critically endangered, unfortunately.
Jeez.
Yep. So that's how much of a decline they had. Because what was the species? I thought we talked about it where they was like...
We totally did talk about one recently like that.
It was like they all walked off a ledge.
Oh, yeah.
Remember that?
I can't remember.
The crabs or something? I don't remember. Like I said earlier, it's like 15, 25, or they keep everything I kept saying said 16 to 24. I'm like, you're breaking your own rules here. But that radial symmetry, again, remember what we talked about earlier, is all those limbs are independent because it's all not centralized. So now think of, you have your sea star, but now it's amplified. So all of those are different. So if that thing's going to be latching on and sucking onto your face,
it's a lot of coordination.
Starfish, as we talked about, they're not supposed to be fast. Most of what we know about them, they're slow movement, deliberate pacing, slow and steady wins the, I guess, water vascular race down there. Most of what we know about them sets the exception that speed just isn't part of the deal. The sunflower sea star breaks that rule completely. It is the fastest moving starfish species that we know of, which, given everything we just talked about, really is saying something.
Oh, yikes.
Let's do some math here that we're both horrible at. So we said it can be up to a meter, right?
Right.
So 3.3 feet. So it can reach speeds of about 3.3 feet per minute. So it's almost like going its body length. You know what I mean? Like doubling, but it doesn't like up and over itself. You know what I mean? But it's like its body length per minute. So, I mean, considering...
Yeah, creepy.
Yeah, it's creepy. But they can move that fast, one, because you think about how many arms they have, which is that many more tube suckers. So they have up to 15,000 tiny tube feet on the underside that move across the seafloor. So that's how they're able to move. I mean, I guess as fast as they could. Like,
yeah.
For having no muscle,
as fast as that kind of organism could.
Yeah, with decentralized 16 to 24, whatever different things, like that's actually pretty fast here. And to think about it, like when it moves, the reason why this one is able to pick up speed, and really any of the starfish, because any of the starfish, they are typically faster moving relative here, because the arms, they don't just drag behind it. And I've actually answered this before. People think that whatever the first arm is like the brain, and then it's just kind of like the other ones are coasting behind it. And even though they do operate semi-independently, it's still just in sync. So even though it's all moving together. So I've explained it again to a lot of people before that think that it's dragging it. You know what I mean? But it's like
kind of like an octopus moves more like that.
Yes.
Like I feel like an octopus reaches and pulls
and reaches and pulls. Yeah.
But you're right. This is like a almost like it's got skids on the bottom where it's just
yeah, like more of a conveyor belt kind of movement where it's all going together.
Which makes sense with the hydraulics.
Yeah, exactly. So it's easy to assume that this, like a starfish or any of them, are passive animals, slow, harmless, mostly just existing on the seafloor. But sunflower sea stars, they eat urchins, mollusks, and a wide range, and they have been proven to hunt. They have been seen to move toward prey, pursue it, and use its 2 feet to actually pin it down and manipulate it in because again, it has like a bajillion arms, so like it's a lot more, whatever I want to say, dexterity. It has a lot more dexterity compared to the other ones, because you have I have 5 fingers. If I had 24 fingers, imagine like how fast I could solve a Rubik's Cube, right?
Right.
Really fast at that point. So those same suction cup-based feet that help them move across the seafloor are strong enough to hold struggling animals in place, and they've seen it, which gets back to terrifying. So the reason sunflower sea stars matter isn't just because they're like strange, impressive compared to the other sea stars on their own. They do actually play a critical role in the ecosystem they live in, especially in kelp forests where they're often found. And the relationship is pretty straightforward. Sunflower sea stars eat sea urchins. Sea urchins eat kelp. As long as the sunflower sea stars are present, urchin populations stay in check, kelp forests remain healthy and dense, which is the balance that you want.
Right. A lot of things rely on kelp forests.
A lot of things. So when the sunflower sea stars disappear, that balance breaks. Sea urchin populations explode, which we've seen, and then they start to go ahead and just overgraze on the kelp, and huge kelp forests can be gone. And
yeah, it's why predator, like, it's same old story with all the predators. Remove a predator and, yeah.
So once what a thriving kelp forest can turn into what scientists call an urchin barren, which is an area stripped down to the rock with far less life because all kinds of things, like Laura said, rely on it. So even though you don't think about it, this is an example of a keystone predator. Yep. And it's a species that has a huge impact for how relatively like small. I mean, 3.3 feet. I mean, it's still
compared to the ocean.
Yeah. But yeah, compared to the ocean, it is pretty small. But remove it, and that whole ecosystem that it participates in and lives in completely crashes. So I mentioned earlier that the rapid decline. In the last decade, sunflower sea stars have become the focus of intense scientific concern because of something called the sea star wasting syndrome. Starting around 2013, populations along the Pacific coast experienced massive declines. In some areas, sunflower sea stars dropped by more than 90% in just a few years. The disease causes sea stars to develop lesions, lose arms, and rapidly deteriorate. Among everything else that it's facing. So then you have this, combine it with ocean temperatures rising, like all these different things.
Which could be conducive to the disease, too.
Exactly. And so this species that relies on regeneration to survive, this was especially devastating. If it's like losing arms faster, they can regenerate and stuff. It's done. So instead of being able to recover from damage, their bodies just seem almost like too overwhelmed because they're losing too much, too many. Too much at the same time. So what makes this particularly challenging is how much we still don't know. Scientists are still working to understand the exact cause of this syndrome, why it spreads so quickly, and why some sea star species are affected far more than any other. So it's not just this particular one.
Yeah.
It's any sea star. It just happens to be this one is a keystone predator that we see the effects of it declining way more than what we would on other sea stars. And that's an important part because oftentimes whenever we think of species disappearing, we think of, oh, that was forever ago. That was a long time ago. This was not long ago at all. And we saw a very quick decline in it.
Yeah.
So it's definitely a keystone predator species that a lot of other things rely on it. And it's pretty neat, but unfortunately it's rapidly declining and on its way out.
Yeah, that sucks.
Yeah.
I do love learning about like top-down ecosystem control.
Right? Face suckers.
Ugh. Yeah. I really wanted to talk. My species highlight is really, it's not just one species. It's the genus of sea cucumbers. And really, maybe they know enough about one specific species to have filled this time, but I don't think so. So I just wanted to cover how cool they are because I've liked sea cucumbers ever since I was young. Found that one that I was saying, but also they're just cool. Like they're like a weird animal. So like I said, generally they're olive green and black, but these organisms have a huge variety in appearance and even behavior. Like you can't just be like, you've seen one pickle, you've seen them all. Apparently not.
Dang it. Yeah.
So some, though mostly drab, some can be really colorful, like the blue sea cucumber, which is blue. Some are transparent, and some, of course, are even bioluminescent because...
Of course, because we're the only freaking thing that doesn't glow, damn it.
Yep. They typically move slowly as adults because, again, the larva stage thing like throws a wrench in all this stuff.
Of course.
Where depends on the species, like how much. Some swim in the open ocean, like the headless chicken sea monster. True name. Others burrow like worms. So, like...
What the heck?
Like I said, this is just... Yes, they're all sea cucumbers, but they have very different ways of living, and they look very different. Reproduction is also variable. Some release eggs for external fertilization. Others hold on to and brood their eggs. And in a few species, they just half themselves like a worm. They're just like, And now there's two of us.
When you look like a giant, like, let's not reproduce that way. Like, why would you? Let's find something way more fascinating.
So yeah, like there's no reproductive is off. My favorite behavior that I remember learning as a kid, and to this day, it's definitely the most fascinating thing about sea cucumbers, is their specific behavior called evisceration. So a few species spit internal organs out to distract predators when they're threatened. Okay,
Could you
and I'm not
imagine, like, if we did
just power puking.
Yeah.
Power puking out your organs. And, well, I mean, it's not even out the front. Usually it's out the back.
At the back, yeah.
It can be a lot of different things, too. So sometimes, I mean, we're talking gestational tract, sometimes gonads, sometimes the entire respiratory tree, like just all of it inside out.
I'm not going to lie. There was one time I had food poisoning and I really thought that this was a possibility. So,
You're right. I feel that.
I was on the verge.
You're like, yeah, I can see
I'm like,
that.
surely something.
My lungs are about to fall out. Just...
like something's got to give. Something's got to give.
Yeah, gestational tract, that was already,
Right.
Sometimes it's not organs. Sometimes it's actually just these specialized tubules, which is really gross. If you look up a video, it's just all these white tubes that come out, which look like worms. So it probably freaks out whatever's going to eat it. It's just like, what the?
Yeah, right.
And because they're echinoderms, everything they lose can just be regrown. They don't need that respiratory tree. They don't need those gonads. They'll just grow new ones.
Jeez.
So eviscerating themselves is just amazing. Some can excrete a toxin at the same time, which I did not know. I didn't know that some were toxic. And some can dissolve their body walls when grabbed or ditch an injured part in 30 seconds. So, like, touch, just like...
But also, I wonder if you poke
it's
it,
not
right?
instant. It's just...
Yeah, so it takes 30... You're like, oh, cool, squishy, and then you set it down, and it's like... I'm still doing it. I'm still doing it. I'm still doing it. You know what I mean?
Like, dropping it. I'm dropping it.
Like, it's just, it's already going. Like, you've already put it down. You've swam away, and it's still like, like, having that reaction, and it can't help it.
It just dropped its butt. Because it's just a long tube. So, like, what does it drop? Yeah. Highlights of sea cucumber names, the best ones that I could find. Here we go. Sea pigs, which we actually have talked about before in this podcast.
Yes.
Sea pigs, look them up. So cute. Red sea gherkins.
That's a good one.
Yes.
Yeah.
Sea apples. The headless chicken monster, which I brought up earlier.
Yeah.
A gummy squirrel.
Gummies. Now they're just having fun. They're like, might as well name this something else random.
The pink see-through Fantasia.
What?
These sound like weed strains.
Yes.
Like the
It does.
Oh, some pink see-through Fantasia. and last but not least, the donkey dung sea cucumber, because it just looks like poop.
Yeah, that one's pretty self-explanatory. Again, they're like, you know what that looks like? Donkey poo.
Yep.
Like, that's
donkey
it.
poo. So I'll also mention, why do they matter? Because they do. All living things matter, and here's why. For the same reason as worms. So these guys are also slow motion hose. Throwback.
Right? I was just gonna say, throwback to our first season, when the first time that I genuinely really lost it on our podcast of laughing at an inappropriate joke is when Laura said, completely innocently, that earthworms are basically slow motion hose, and I lost it laughing.
They're just tilling the soil. Tilling the ocean floor.
Yeah.
So they recycle nutrients throughout the ocean. They aerate the seafloor if they're burrowing ones, okay?
Okay.
They remove harmful bacteria, reduce harmful algae, host other creatures on or in their own bodies. So some of them have like anal things that live inside of
visitors?
Them. Why not? Yeah. So like, no,
not?
permanent house
Come
guests,
on in.
not visitors. Permanent residents. They're
Come
like,
on, I got some space. Like, just tuck yourself
Don't
right in
lose
there
much.
and just like,
Yep.
right? Gosh,
it's a thing.
I gotta look into that later, because is it symbiotic, or do they just collect friends that they're like, this looks cool, and just like stick it in a cavity?
Ew.
And they're just
Stick
like,
it in a cavity. I'm pretty sure it's the anus too. I'm pretty
it's
sure
gotta
it's
be.
that and not the
Yeah,
mouth.
it's gotta be. Yeah, because they're not
Because
like
they
a
do have a
squirrel.
mouth and an anus, but
Yeah, because they're not like a squirrel, right? So where else are you gonna
keep it
put
in
it?
a
Like
cheek.
up in your booty
just-
pocket, like just.
and
just say,
And it's just coming
say
in
that
and
for
out.
later.
It's just eating what they eat.
So gross.
Little do we know, these sea cucumbers are sea freaks. Like, they're
Kinky freaks of the ocean,
slow motion nose.
right?
Gives a whole new angle to it. So yeah, I actually specifically pulled this snippet from an article. In one 2021 study on an Australian reef, estimated that lollyfish, or black sea cucumbers, tilled around 71,000 tons of sediment per year, which is heavier than 5 Eiffel Towers.
That's
That's
so
one
much.
spot. That's in one spot. They're just
Yeah, that's nuts.
Yeah. So they are recycling everything in the ocean, even if they're not burrowing.
Yeah.
Just they're sediment and filter feeders. So they're just
That's crazy. That's a lot.
Recycling.
That's not
Yeah,
even a
that's
slow
just
motion
one
hoe.
spot.
That's like
Yeah.
a fast hoe. Like
That's fast hose.
that's because again, you think about that much in a year for them not having like the water vascular system.
Yeah.
You know what I mean?
Well, just,
like that,
it's that or how many there are,
right?
Which is also like
or both,
it's a lot.
Like that's crazy.
little black sea cucumbers.
Yeah.
Unfortunately, sea cucumbers are eaten in several Asian countries, and at least 16 species are threatened or endangered. Remember, though, hold on, let me go back up to where my holothyroidia. There's 1,100 species, so 16 out of 1,100 still part.
Honestly, yeah. They're doing a lot better than other species are.
Yes.
Or other groups.
And I'll just end it on a fun fact, which is a group of sea cucumbers is called a pickle.
Naturally. Make sure you guys go check us out on Patreon. If you can support us, you can. That'd be huge. We are now in 122 countries listened to. We've seen a spike recently. So yeah, keep listening and keep telling your friends about it. And until next week.
See ya.
Ever wonder why a bat might glow? Or how frogs made it to space long ago? Dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Why?